Uh, Welcome back. Uh, Hello, good morning, good night, or anything that you want to say, just say. Forget about that. So, I remember telling in last video that I would post one or two videos every month or so. Uh, Apparently, or you may say evidently, I was wrong. I stated it falsely. Hmm. Like I wasn't getting any ideas or so. Keep that aside. So uh, let's start with this video. The first thing that I would like to claim is that I don't claim to know anything about graph. Uh, when just know the basic definition that the set kind of notation the definition that it has. So which is what I will be stating right now. So a graph G is just like uh, just an object which has an associated set of vertices and a set of edges. Now, this doesn't necessarily be meant to look like something of this sort or so. Uh, this is just a representation for this. Like, um, I shouldn't draw both. Like, kind of representation, and this has nothing to do with this. Like, it has something to do with this, obviously, but um, this has some higher properties compared to this because there are angles if you realize if I draw something, but that is not something which has come out because of those definitions, those sets, but rather that is just human kind of thing because we need to draw something. So going forth with the definition, so the vertices set cannot be an empty set, because if vertices set are empty, then edge set has to be empty. So what you're representing is basically nothing. So you cannot represent nothing. Like you can, but why would you? Let's make our life simple with what we have. So vertices set cannot be empty, so it should have some elements like a b c, wait, a b c, and edge set can be empty or non-empty. It's like which goes both way. Like an edge set is basically um, a set which has um, like a set of two distinct elements from. It doesn't need to be two distinct elements, but two elements from uh, this vertices set. So basically, it can have some set like this, 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 and so on. Enough of this definition. So this was the whole definition that you needed for this kind of question, not question, but like good something. This video is not about any question that something like I can't explain what it is. So basically you have the question starts now. So you have a point like a b c. Let's not write a b c, but 1 2 3 dot 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 dot, dot. These dots are not these vertices, but something like continuation kind of thing. So you have n vertices, and every former is from like every kth uh, vertex is connected to every k plus 1 vertexes. So no, like every kth vertex is connected with every k plus 1 vertex. So and now the question is basically like um, every this kind of element that you see, like there is a vertex here, there is a vertex here, there is a vertex here, there is uh, edges connecting them like this. Then in every new step, every next step, you would connect those kind of uh, non-fulfilled triangle by something like another edge connecting the rest of 2 points. So basically what will happen in the first step, um, I'm considering discrete step by the way. So in first step what will happen is like uh, mm, 1 will get connected to 3, uh, 2 will get connected to 4, then 3 will get connected to 5, and so on and so forth. It goes and on forever, not forever but till like n. So basically my like what we need to show it that like what we need to find out is like the number of steps that it will take for this for the the third vertex to be connected with the last vertex. Yeah, so that is basically the question. So here I go with the solution. uh, oh wait, I need to erase this. This is something that will come afterwards. Yeah. Yeah. Oh wait, don't say that. Okay. So as I said, in zeroth step, which is like what you have initially, you have basically connections which include one jump. Now let's move to first step. First step. Yes. In first step, the point which is connected like 1 to 1, and now there will be another edge which connects k minus 2 point with the kth point. Yeah, basically you can check that there will not exist any other kind of edge that is being created, but that left to you, left to the watcher as an exercise. As an exercise for the watcher, as the book said. No, not book, but audio, whatever. So, in first step, you get ability to jump twice. Somehow, someone gives you. I don't know who. Don't ask me. Neither do I. Second time step. So now, basically, all the points are connected to 2 points away from them. The two and the second and the tooth point away from the first point is connected to the next point. So basically there can be another, like basically what I'm saying is this, right? So this, consider this to be a single jump which comes from here, and this to be a single jump which is already there in the question itself. So now there can exist another kind of jump which includes 3 jumps at a time. Nice. 1, 2, 3. These are the new kinds of points that are created now. Also notice that that second point from the first point, no, wait, the third point from the first point is now connected to the fifth point from the first point. Yeah, basically here. So there can exist another edge which goes from here to here, right? So basically what you have is new 3 jump accessibility and 4 jump accessibility. Similarly, like you're seeing a structure here, right? Initially you had one kind of jump. Don't consider this. Okay, can't consider this, don't worry. Third step, I won't do it, but you can go with the similar kind of argument and claim that the new point should be 5, 6, 7 and 8 basically. Now let us argue that every kth step will lead to new 2 k minus 1 points. This statement agrees with all of this because you get like 2 points for every for the second step, which is basically 2 to the power 2 minus 1 equal to 2. So assume that every point gives 2k minus 1 new points. So basically, after k steps, you have 1, 2, 3, 4, dot, 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 2 k kind of new accessibility. You can actually see why I wrote k here, because if you sum all the possible new steps that you get, for example, here 4, here 4, here 2, here 1, here 1, you will get like 4 plus 2 plus 1 plus 1, which is basically, I can, oh damn, 8. 8 is basically 2 to the power 3. 3 comes from here basically. You can check how that works out, like GP sum, if you know. I hope you know. I don't hope, but you should know. Anyway, I don't care. Neither should you. I mean, you should care to understand this, but still, anyways. Yeah. So after k steps, you have 1 to 2k kind of jumps which are possible, right? So let us see from this only how we can generate more 2k points for the next, for like the k plus 1 step. Okay, so you already have 2k point, 2k kind of jumps with you. Now consider this: every 1 point is connected to k plus 1th point, which comes from this. Now every k plus 1th point is connected to k plus 2th point, k plus 2nd point, k plus 2th point. Yeah. So basically, you will get more kind of jumps which goes like 2k plus 1, 2k plus 2, dot, 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 2k plus 2k, which is basically, it is extended our set from 1 to 2k to 1 to 2k dot 2k plus 1 comma dot 2k plus 1. So basically, with every k step, you get in total 2k kind of jumps, and we need to find the step at which you cover from 1 to n. So if you consider how many steps there would have been just before the step which leads to the connection from 1 to n, you should have this inequality, right? Like 2 to the power k should be less than n minus 1, because to go from 1 to n you need n minus 1 steps, and in kth step, like in kth time step, like this step and time step that I'm talking about with this k is different. Like I hope you understood that. Yeah. So every like after kth time step, you have 2 to the power k uh, kind of jumps that are possible. So, and those 2 to the power k elements are 1, 2, 3, till 2 to the power k. So just before this step, which leads to the connection from 1 to n, you have the maximum connection, which is let's say 1 to k plus 1, should be less than the connection length required from 1 to n, right? So that is basically what I'm writing here. This is the jumps that are required to go from 1 to n, and these are the maximum number of jumps that you have at k step. And remember that k plus 1 is our answer, because this is the maximum k. This this is the maximum k for which this inequation is satisfied. Let us solve this inequation. Take log base 2 on both sides. You will get log base 2 of 2k less than log base 2 of n minus 1. This is basically k is less than log base 2 of n minus 1. Right. Am I missing something? Yeah. So k plus 1 is our answer, right? Since k is just less than log 2 n minus 1, k plus 1 should be just greater than log 2 n minus 1. Graphically, what that means is like 1, 2, all the numbers. I won't be writing n. I was going to write it, but yes. General. Suppose here you have this number. So k should be less. K is an integer. Mind that. To be frank, a natural number. Not a natural number, but a whole number. K should be less than this quantity. So this can be k, which means k plus 1 has to be this. And how do you remember a notation which goes from, which takes a number from here to here? Yeah, it's like basically a roof function. Exactly, like if you have something in this range, something in between, the roof function that just takes it from the the from in between to the higher number, higher integer, basically. So basically, k, like the step, let's not write k, but k dash, yeah, k dash, the number of steps, that the number of time steps that would take to cover from 1 to n, to forge a connection between them, is equal to roof function of log n minus 1 base 2, obviously. How could I forget that? That is basically it. I don't know why it is nice, but I feel that it is nice. Anyways, see you again someday. This time I won't claim after how many days I will post a video, but let's not claim anything. Bye for now. Uh, supposing that someone says this before Diwali, happy Diwali. Oh wait. Uh, Happy Diwali is also a roof function, right? So, like, if I say Happy Diwali, like this is the year 1, this is year 2. So, if I tell Happy Diwali here, which means I'm telling Happy Diwali for year 2, which means Happy Diwali is kind of a roof function. Oh my god, this is some kind of dangerous analogy, and you might like to keep this analogy in your head. Bye. Maybe bye. No, finally bye.